Welcome back. So let's move on to variable data type. Variable data type are often used to store different values and hold them. They are basically a container and they will hold a particular value until it is reassigned to them again. That is, these data types are going to hold their previous value until we intentionally assign some new values to it, and something known as procedural assignments are used to assign new values or old values back to these data types, and these procedural assignments are used within procedural blocks. Again, we will talk about the procedural assignments and procedural blocks in upcoming videos. And to illustrate the variable data type, we can use the schematic. Here, a D flip-flop is shown, which stores one bit of data, right? So, it can be designed using a variable data type as they can hold values. We can use a variable that holds a single bit to design the D flip-flop. So, we can design any flip-flop using a variable data type. Now, let's see different types of variable data types. Firstly, we have the reg data type. It is the most commonly used data type which we will be using, and from the name itself, we can see it's just a short form of register. That is, a register stores value. So this reg data type will also store values. Usually, reg data type is used to model the behavior of flip-flops, and it is used for the output ports of the design. So any design will be having input ports and output ports, and the reg data type is often used for the output ports of the design. Let's just go to the EDA playground and see it's working. Here I have defined a test module in which I have made the output out as reg. Apart from that, we are also creating a reg type variable. Now inside the always block. Now this always block is a procedural block. Now in this block, we are assigning the value of input in to the variable whenever the input is going to change. So as you can see in the sensitivity list of, there is something known as sensitivity list of the always block. So in the sensitivity list, I have just mentioned input in. So it just states that whenever the input in will change, this procedural block will get executed. So this always block will execute whenever the input in changes. Now we assign the value of variable to the output out. So again, it's just like we are connecting the input to the output, but here we are using the reg data type variable. Now we can see the same in the waveform. Before 5 nanoseconds, we can see the output is following the input. And even after 5 nanoseconds, when we change the input to binary 1, then also the output followed the input. Now let's see some of the numeric type variables. Firstly, we have the integer type variable. This is the most this is mostly used in internal signals of our design rather than ports. By default, an integer variable is a 32-bit signed number, and we also have the real data type, which is used to store non-integer numbers. It is a 64-bit floating point number, and we know implementing the floating point arithmetic is hard, so the real data type is not synthesizable. That is, we cannot convert it into hardware. Let's go to the EDA playground and see their working. Here we have defined an integer a and a real type variable b. Now in this code, whenever the input in will change, the value of a will increment by 1, and the value of b, as you can see, will be equal to the value of a at that particular instant, divided by 2. And here b is a floating point number. So we will get to see some decimal numbers in the answer. Let's just see the waveform for more clarity. So in the waveform, we can see that the input is changing every 5 nanoseconds. That is, it is toggling between 0 and 1. I have just coded this particular feature in the test bench. Now, at every toggle, the value of integer a is increasing by 1, and we can also see the results. And we can also see the results obtained after dividing a by 2, which is equal to b, and b is a real number. So we are getting basically some real numbers here. Then finally, we move on to signed and unsigned variable. It was introduced in 2001 standard of Verilog. We know a variable can be assigned negative numbers, but let's take an example of the integer type variable, which is a signed number. We can alter its behavior by using the unsigned keyword. Let's just see the code and the working, and we will understand the same. We have the same code as before, except we have defined an integer with unsigned attribute and named it as C. We can see that A and B are same as before. C is an unsigned integer which is initialized to 1. So we cannot assign negative values to C. If negative values are assigned, then they will be wrapped around modulo 2 to power 32 in this case, because integer is 32 bits. So if we assign some negative numbers to the unsigned variable, then they get wrapped around 2 to power n, modulo 2 to power n. So at the first input toggle, the value of C will change and will be multiplied by -1. So the result should be -1 that will be stored in C. But we can see some large value in the waveform. It is because -1 wrapped around 2 to power 32, and the value which we are seeing is 2 to power 32 minus 1. You can calculate the same and see the results for yourself. If, say, C was assigned -2 somehow, then we would be seeing the result 2 to power 32 minus 2. So it is wrapping around modulo 2 to power 32. So we finally we have the array data type, in which we store a group of variables of the same type. So now array is altogether a big topic to deal with, and we will cover it in the next video. Thanks for watching, and let's move on to arrays.